Morning all of you. Real nature of matter or two syllabus we have started with. Do remember all these topics are really easy scoring as compared to the part 1 topics. For most of the students I can definitely say part 2 syllabus, among that the concept of photons, atoms, nuclei, all these are very easy scoring. Now today, after finishing our concepts in the previous session, let us take up this session for our examples on those concepts. And also this session I would like to make use of one more important concept for our examination. These many days for all the topics, we did many examples based on the numerical values, simplifications and so on. We also know that NEET examination at least will come across one or two graphical questions as well. Maybe representation of graph or maybe analyzing a graph and finding some values, such things. So today's session I would like to throw some light on understanding of a graph, because this concept, graphical representation, it is the case with each and every concept that we have learned. Many equations we have derived or expressed. For all of them we can use this concept of graph. So first let me take up minimal things about a graph. Now, to begin with, 4 things are important for a graph. First one is, what is the shape of the graph? Second one is slope of the graph. Third one is the intercept of a graph. Fourth one is the area under the graph. Now let us come to one by one. First one is the shape of the graph. See, the shape of a graph depends upon the particular relation between those two parameters for which now we are plotting a graph. X-axis, y-axis. Now here I am representing that small y, the parameter calibrated on y-axis, and small x calibrated along the y-axis. Now here I would like to show 4 to 5 very popular cases, not moving ahead. 4 to 5 popular cases. One is straight line. When do we get straight line graph? We will find the equation in this form: y is equal to mx or y is equal to mx plus c plus or minus. Here also I can say y is equal to plus or minus mx. So this is one equation where we get the straight line. Looking to the equation, we should understand whether it is in this form or in this form. Then in this notation, this m represents slope. M represents slope, and that is a constant here you will find. For any straight line graph, slope is constant, which we calculate as y2 minus y1 by x2 minus x1. That is how we calculate, right? M, the slope, which is constant. Now what is this case of positive and negative? Look here, I show a graph in the first quadrant. Here quadrant also plays an important role, such that here I give a convention. We now show the graphs in the first quadrant. Whatever rules that we say for first quadrant, the same rules also hold good for third quadrant as well. Let me repeat. The rules for first quadrant and third quadrant are the same with respect to the slope, and similarly the rule for the slope is same for second quadrant and fourth quadrant. And now most important point is, the first quadrant rules and second quadrant rules are exactly reverse, opposite to each other. Now let me show what do I mean by these things. Now this is x-axis, y-axis, a graph is shown. This is y is equal to mx. This is straight line passing through origin with the positive slope. So this is positive slope in first quadrant. Positive quadrant, and this is passing through origin, then we will get y, this is equal to mx condition. So this represents y is equal to plus mx condition. Now the rule is the same for the third quadrant as well, I have told. Supposing if this is first, second and this is what is third quadrant also this is positive slope. Now how to calculate slope? You know that y2 minus y1 by x2 minus x1. Even that also you take final value whatever is given, and this is what is initial value that is given. Suppose this is what is y2 and y1 I take it as 0. Supposing this value is what is x2 and here this value is x1 coinciding with the origin. So whatever we find on the y-axis, we will take that as dy, and whatever this complete scale that we see on the x-axis, let us take it as dx, that dy by dx will give the slope, the positive slope. Now let us show another straight line graph with the negative slope. Now you see, this is a graph that is represented with negative slope. Actually, what is the meaning of this positive slope, negative slope? To give more comfort in that definition, you see here, as x increases, y also increasing. This kind of x increasing, y increasing, or x decreases, then y also decreases, such cases the slope is positive. Now here, what is the meaning of the slope being negative? Here you can see that as x coordinate increases, y coordinate is decreasing. This is a kind of inverse relation. When you understand that the parameters are inversely related, then we will find a straight line graph with this. This is negative slope. This is negative slope. And remember, when it is a straight line, the slope is always a constant. Positive value or negative value is always a constant. You see y is equal to mx. Other than that, supposing here I have shown y is equal to mx passing through origin. Now this is also a straight line graph. This is also y is equal to, I get it as mx plus c. Y is equal to mx plus c. Or else, supposing, now here another meaning you have to take. This m of course for slope, and this C is for intercept. Understanding intercept is very, very important. See here, this is the term y. Therefore, whatever C we get, it should be a y quantity. This C should be y quantity because mx plus C you are doing, therefore the C has the dimensions of y. Therefore, now here you find that, yes, if you extrapolate this graph, this is what is the O. Suppose if I call this as capital Y, this is what is called as the intercept, y-intercept, and we got it as negative intercept. Negative intercept. Therefore, whenever we take a graph when we say intercept, we should be careful about which intercept, whether it is y-intercept or x-intercept. See here you get it as y-intercept, whereas O, if I call this as capital X. Now here, OX and OY, two intercepts are there. Now in the given example, which of the intercepts we have to make use an important thing depending upon the data. So OX and OY, X-intercept, it can be positive as well as negative. Y-intercept, yes, this is also can have both positive values and negative values. Here in this example, what do you find? The x-intercept is positive, y-intercept is negative. Maybe other case if we consider, like suppose I take one more graph like this. I have a graph straight line. This graph, what we find is y-intercept will be positive. Then if you extrapolate this, you will find that it will have negative x-intercept. So comparison of intercepts may be one such important criteria for us, and comparison of slopes is also an important thing for us. Earlier I have told this is about the first quadrant, the rule is same, third quadrant. Supposing now if we write the rule for the second quadrant, and of course the same for fourth quadrant, and I have told you it is exactly the reverse of what we can have the convention in the first quadrant graph. The first quadrant we said this is positive slope, straight line with positive slope. Therefore, here in the second quadrant, this, if this is what is positive slope, this is what is negative slope. Similarly, if this is what is negative slope, this is also negative slope in the fourth quadrant. We set the convention by 1 and 3, the rule same. Therefore, this is a negative slope, and this straight line was negative slope in first quadrant. Therefore, any graph in the second quadrant with such thing, orientation, it will be a positive slope. And to avoid any confusion, as I have told you, look at that trend. If x increases, what is happening to y? Or if x decreases, what is happening to y? Both increasing, directly proportional, and the slopes will be positive. Both decreasing also, slope is positive, but one increase, the other decrease, it will be an inversely proportional case. And now when you are comparing, one more important thing I am telling you, for the most average understanding also, here I show one important thing. So it is about the positive and negative slopes of a graph. Now here you see, supposing I have two graphs like this. Then this is graph 1 and this is graph 2. Then they have said that which is more, which is steeper, it is said sometimes. Steeper graph. What is meant by steep? The one with the higher slope we call it as steeper. Therefore, when you look at these two graphs, what is our understanding? This curve 1, this straight line graph 1 has more slope as compared to the second one. Therefore, this we call it as a steeper curve. So, this is also one terminology come across in the examinations and those examples. So, this is about straight line graph. And most important point here is, how do we consider that y and x is an important thing? See this example. Supposing I have an equation, I am writing it as v is equal to gt. One equation is there. Suppose this is velocity of freely falling body with time, with initial velocity being 0. V is equal to gt. Supposing now if I draw a graph between velocity versus time. Velocity versus time on x-axis, velocity on y-axis, then this g is a constant, we know that for gravity, and therefore it is v proportional to t, which is y is equal to mx. Is that okay? Y is equal to mx, where this m now referring to g. That comparison you need to know. So slope is equal to gravity. Slope is equal to gravity. Therefore, this is a straight line graph that we get for v versus t. Now, earlier I have told you comparison of slopes. On the surface of the earth at same place, if 2 or 3 experiments are conducted and velocity time graphs are drawn, then this g is a constant at a given place. Therefore, we cannot have different slopes. We should get same slope. Rather, supposing an experiment is conducted on the surface of the earth and then it is moved to surface of moon, then what will be the change that will be expected in the graph? See, a very, very difficult question that I have created. This is supposing the velocity time graph on the surface of the earth. Which of the following will represent velocity time graph on the surface of the moon? Then we know that the slope of this graph represents acceleration, and that acceleration g value on the surface of earth is 9.8 meter per second. When it is on the surface of the moon, what happens? We know that gravity is lesser. It is 1/6 of the gravity of earth. Therefore, the slope of this graph should be lesser when the experiment is conducted on the surface of the moon. Therefore, for this velocity time graph on earth, the velocity time graph on moon will be a straight line again, passing through origin again, but slope is lesser. It cannot have same slope, it cannot have more slope. it is only the case of having lesser slope. So this is number one. Second point also you see that sometimes I said one relation just now we have mentioning about these wavelengths and all. We have de Broglie wavelength lambda is equal to h by p. Now supposing if I am drawing a graph between lambda versus p, lambda versus p graph will not satisfy the equation y is equal to mx. See here, this is what is constant. Therefore, if I write it as y is equal to, this is m times 1 by x is there. Because if it is graph between lambda versus p, it is not in the form of y equal to mx. It is in the form of y equal to m times 1 by x. Therefore, such graphs will not be straight line. Got the point? The nature of the equation is very important to look at. Now, having said that, definitely it is not in this form. But now having said that, if I want a graph between, see this is what is the change, lambda versus 1 by p graph if it is asked. Lambda versus 1 by p graph is asked. Then this lambda happens to be y and 1 by p happens to be x. Then this equation is in the form y is equal to mx. That m for, yes, h here again a constant universal, and 1 by p we have taken it as x. Therefore, this satisfies the condition y is equal to mx where x is 1 by p. For such a thing, again now the graph becomes straight line. Therefore, in this equation, what is the difference that you find in v is equal to dt, velocity versus time, straight line passing through origin, lambda is equal to h by p, lambda p graph is not straight line, lambda versus 1 by p taken is straight line passing through origin with the constant positive slope. So this is how we understand what is the parameters calibrated on x-axis and y-axis is a very important thing to see. We have to discuss much more things also because of the limitation of time. Here I am stopping for the case of straight line. Now let us take up the case of non-linear curves. What will be the case with non-linear curves? What about the slopes and all we will now discuss. Now let us see the case of non-linear curves. When do we get other than straight line graph? In that particular cases I am telling you specific cases for our examination. Most of the expressions that we come across in our PU physics would be the parabolas and the rectangular hyperbola. Apart from that, we can also take some other curved graphs as well. Now you see parabola. When do we get a parabola graph? Then again, it's a very popular example or popular case with your mathematics also. Y is equal to some constant times x power n. That n is also equal to 2. Y is equal to c times x square. Earlier we said y is equal to mx. It was first degree equation you call popularly. Now other than first degree equation, any relation that we come across other than first degree, it will be non-linear. In that specifically, if it is y is equal to constant times x square, then it will be a parabola. Now, rectangular hyperbola, whenever we have this relation y is equal to some constant by x, that is here the result is y proportional to x square. Y proportional to x square, yes, it is parabola. Y proportional to 1 by x, because this is what is the most popular case with all the graphs that we come across in our physics. Most of the graphs that we come across, y proportional to 1 by x is rectangular hyperbola. Now let me show y proportional to 1 by x square. This is a graph. Again, we have parabolas with different orientations that is possible. Now you see, if this is what is the case that I am representing. Suppose I take up one equation, S is equal to half gt square, you have expression, same freely falling body, I said H is equal to half gt square. Now H versus P graph, P versus H graph. One more time I am telling you, look at this x coordinate. This is not t square. It is only said as a t. Supposing if it is said as a t square taken on x axis, if x is taken to be t square, then it is again y is equal to mx it happens. Is it not? Then it will be again straight line passing through origin. So that is to be taken care of calibration on the axis. If this is the t, this is the graph that we are getting. Now when it is the graph, first quadrant graph we have shown, please look at this point. Here the slope is gradually increasing. It is not a constant slope, variable slope. In that variable slope also, what is an important observation? It is gradually increasing slope. This is gradually increasing of the slope. Whereas, supposing I can also have another curve like this. Suppose if I have a curve like this. This is also your parabola that you are getting. Now the point I am telling you. In general I am telling you, you leave that parabola and not too much of mathematics, at least for our NEET and CET graphs. Let us take curve. Only curve let us take. Let us take curve. This represents, let me take that as a general case, y proportional to x power n and n is greater than 1. Y proportional to x power n and n greater than 1, then it is gradually increasing slope. Supposing here I show y proportional to x power n and n is less than 1. N is less than 1. Again here we get a parabola like this where the slope is again not a constant variable but it is constantly decreasing slope. So whether we are getting constantly increasing slope or constantly decreasing slope is decided by this index we have given to the parameter of x. N greater than 1 condition, n less than 1 condition. That n equal to 1 is what is our straight line passing through origin case. Now rectangular hyperbola also we have shown. What is the rectangular hyperbola? See, this is what is y proportional to 1 by x. Boyle's law we say pressure proportional to inversely proportional to volume at constant temperature. PV, then it is P proportional to 1 by V, such graphs. So y proportional to 1 by x is what is a rectangular hyperbola. Now earlier I have told you this is an inverse relation between y and x, right? So inverse relation, then we have to see that the slope is negative. Here you see y proportional to x power n in both the cases, n greater than 1. And of course both the cases n greater than 0, positive. Then in such cases we are getting gradually increasing slope and gradually decreasing slope. Here what do you find? Now this index y proportional to x rise minus 1 it becomes. What you see is that negative index, which means there is an inverse relation between y and x. Therefore naturally the slope will be this time negative. So curve with negative slope. This is rectangular hyperbola with negative slope. This one is a non-linear curve that you are getting with increasing slope but positive. Here also decreasing slope but positive. Now here you find, look at this relation, y proportional to 1 by x, or else I will say in general x rise n and n less than 0. So for all such n less than 0 case, what we get is negative slope. Inverse relation, all those graphs will have this characteristic of negative slope. Here you find as x increases, y value is decreasing. If you come from this point to this point, y value decreasing, x value increasing. This is what we mean by the negative slope, the inverse relation between x and y. So this is one more important thing to be remembered. First I have told you about simply parabolic graph or rectangular hyperbola, but let us generalize that afterwards. For our analysis, this much is sufficient, not going into much of the details. Y proportional to x power n, what about the value of n positive or negative? Among that also, n greater than 1 or less than 1. That is what is deciding the nature of these graphs, right? So this is one more case of the shape. Now let us take up one more example. Really, we have the case of the graphs as ellipse and also as well as circles. But very few things are there, or even in the previous examination, we'll find very few of them. Now, the very equation is very important to find the shape, as I told you. If it is the case of ellipse, the equation will be x squared by a squared plus y squared by b squared equal to 1. This is the general equation. Now the point is that how to identify that, because our equations will not be in those standard forms. There our intelligence or there our small common sense which is required. This is equation of a parabola, you know that, and this is for semi-major axis and this is for semi-minor axis, and these are all our definitions. Now let me take up an example to show you where we get that ellipse. See, we have simple harmonic oscillations we did where we have an expression for velocity and displacement. V is omega under root a squared, the amplitude term, minus x squared, the displacement term. Omega, the angular frequency, a constant, omega constant, a constant. Now for a change of x, there will be change in v, right? Increase of x, decrease in v, that is what is you can see. Now actually this is in the same form. Though it is not appearing in this form, afterwards what do you observe? I just rewrite this equation. Squaring on both sides and rewrite equation, I will write, shall I write v squared upon omega squared. Next, here is a squared term, right? I will take this as plus x squared is equal to a squared. Is that okay? Now compare. This is x squared by v squared. Now I am taking the velocity term and displacement term, the graph between displacement versus velocity. Therefore now this displacement term is y coordinate and this x coordinate and this velocity is y coordinate. Now compare, this is x square, a square is what is this, now here it is 1, therefore in this equation this a square value is, no, not even that, you can rewrite this equation in other format. See, v squared by a squared omega squared plus x squared by a squared is equal to 1. Now you can compare. What is that we are getting? A square is equal to capital A square we are getting, which is the amplitude term. This b squared is nothing but a squared omega squared term you are getting. B squared is equal to a omega whole square we are getting. So now for this graph it will be a ellipse, not a parabola or not rectangular hyperbola. This will be ellipse. So that is how I show, see here. Velocity versus displacement. Displacement 0, velocity maximum, and then it becomes 0 for displacement maximum, and other way it goes. Similarly, if we complete it, we'll find it as a parabola. So this is what is the parabola that we are getting. So like that circle, you know that when A is equal to B, in this case the graph will be a circle. So this is about the shape, and most of them, 99% I can say, we get with straight line graphs and non-linear curves, those with the positive and negative slopes. Now let us take up the second character, which is the slope. Now shall we use those simple concepts for our few examples. Here, de Broglie wavelengths are photoelectric effect. We have given some expressions. Now let us see some examples based on the graph. Now the first question I am asking is graph of kinetic energy of a particle, and its de Broglie wavelength. The simplest of the cases. Of course, everything becomes simple if you are good at your law concept, right? Say a graph, kinetic energy on x-axis, lambda on y-axis. Here also comes a question. Which one has to be taken on x-axis or which one has to be taken on y-axis? That can be understood by using the given data, which is changing and which we are fixing and which we are finding. Those we are fixing will be on x-axis, those which we are finding will be on y-axis, like this. Now lambda versus k graph is required. Now for that, what is the relation between wavelength versus kinetic energy? Yesterday's result was lambda is equal to h upon p, which said lambda is h upon root of 2mk, momentum written in terms of kinetic energy. Then what is our result here? The result that you find is lambda proportional to 1 by root k. If it is only the case of finding relation between lambda and k, and even other things can also be done. It is root times capital K. Hope you can see I am writing with a different lambda proportional to 1 by root k. That is, what does it mean? Lambda proportional to k rise minus half. Now this is in the form y proportional to x power n, and n value is negative, less than 0. We said all such cases will be a curve with negative slope. Remember, y proportional to x power n and n value less than 0, it will be curve with negative slope. Therefore here I will now represent the graph. So the graph would be a straight line with negative slope, curve with negative slope. A curve with negative slope. As k increases, lambda decreases is the point. See, this same question but asked in a much intelligent way. How does it look like? Earlier you are asked to just identify the graph, but this time straight away graph is given, and using the graph you are asked to identify another parameter. How? See the improvisation in this example. See the improvisation. Now here I show, this is a given example. Lambda versus k only. Now here two graphs are shown, graph 1 and graph 2. I say, hope you will find it very carefully. This is graph 1 and this is graph 2. Now the question is that this is a graph representing the graph of kinetic energy versus de Broglie wavelength of a proton and alpha particle. Which of the graphs represents that of the proton and that of the alpha particle is the question. Right? Earlier we said simply plot the graph. Now the graph is given. We have to identify the nature of the particle. In fact, we are here doing only comparison. Now identifying the distinction between the particles, looking at the graph. Now, one more time look at the equation. What is the equation? Lambda is equal to h upon root 2mk. Here I said this is 1 by root 2m. See, this slope, this root 2m under root in the denominator will be the term that decides the slope of the graph. Of course, there, as k changing, the slope is changing, variable slope, but that slope is now decided by the mass as well, mass of the particle as well. Therefore, what is that we find? We find that this slope is inversely proportional to mass. Of course, we have the square root and all. Slope and mass are inversely related. Therefore, lighter mass will have more slope, that is steeper, that will now make use for our answer. So in these two graphs, look at those 1 and 2, the graph 2 is steeper as compared to graph 1. Therefore here our answer is that 2 represents the lighter particle among the proton and alpha particle. Definitely proton is lighter and alpha particle is heavier. You know all those masses comparison. Mass of alpha particle is 4 times that of proton. Therefore, in the given example, this first graph represents alpha particle, heavier mass, alpha particle, and this graph 2 will now represent that of proton. Like that. So here what we did is that along with the shape of the graph, here we have also made use of the concept of slope, looking to all the parameters in the slope. Supposing if there is any variation of those parameters in the slope, how to make use for our answers. Is it not? This is what is intelligent questions regarding graphs. Those graphs that we come across in photoelectric effect. All these graphs are very, very important. As I have told you, please be careful about the slopes, the intercepts. All these things are very vital in our discussion now. Now, for photo current, now I am writing few graphs. Photo current, the graphs. First one is the collector emitter voltage versus photo current. One such graph. And this graph you see, when VCE is 0, yes, photo current is not 0. This is one important thing to be remembered. True false statements may be given. When collector emitter voltage is 0, this photo current is not 0. And actually this shows that photoelectrons possess kinetic energy. In the Hertz experiment, too much of details we have done in the classroom. Please go through your class notebook. Now here as VCE increases, initially I value the photo current increases, but soon it will have its saturation, that is does not depend on VCE anymore, it remains constant. So this is what happens. The graph is initially bit non-linear, afterwards it becomes linear. Now supposing in this case, if we extrapolate the graph backwards, graph extended backwards, then this is what is the case that comes. Now this is what is called as the negative potential applied to the collector. This is what is negative potential, which we call it as stopping potential. Therefore here we have the x-intercept of this graph representing the stopping potential. This one graph. Second graph for photo current, we have told that photo current depends on the intensity. So intensity I versus photo current I, again yesterday's result you remember, it will be straight line passing through origin. Why? Because I current proportional to capital I, the intensity, was the result. Now here let us combine these two and to have to show a question here. Supposing this is for intensity I1. Suppose experiment is repeated for higher intensity, what happens? We said earlier, photo current depends on intensity such that an intensity proportion current change will be there, but now look what will be the change that comes. Suppose if it is asked for I2 intensity greater than I1, I2 greater than I1, for that the graph, yes, certainly this is what we call saturated photo current will be higher. Saturated photo current will be higher. Yes, this is what is the graph, higher current, because higher intensity means higher current. Again, you have this non-linear nature in the beginning. And now the most important point is that if we extended it backwards, it will have the same x-intercept, because yesterday we have told that this stopping potential is independent of intensity, depends only on the frequency of incident radiation of force for a given emitter. If emitter changes, then also stopping potential changes, right? So this V0 remains the same, this x-intercept in the negative axis remains the same, whereas it takes a higher value here. Is it not? So intensity versus photo current, one such graph. And also yesterday we have shown that the intensity changes with the distance of the source. Therefore photo current versus distance of the source from emitter. What was the result, you remember? Supposing if I now take instead of intensity the distance of, yes, it is the distance of the source from the emitter versus photo current, then it is not a straight line. Why? Because the result is I proportional to 1 by r square. Now use that inverse relation and n greater than 1. N greater than 1 by r square. Therefore, here you get a curve with a negative slope. Inverse relation means negative slope, not a first degree equation, therefore a curve. Therefore, a curve with a negative slope will get I proportional to 1 by r square. I versus r graph. I versus r graph. Like this. Afterwards, for photoelectric effect on graphs on kinetic energy. Graphs on kinetic energy of photoelectrons. Now, instead of kinetic energy, it can also be said kinetic energy or stopping potential. One and the same. Stopping potentials. Stopping potential graphs. Because this kinetic energy and stopping potential are directly related. You can see K maximum is equal to, we said E V naught. So if K increases by 20%, V naught also increases to the same percent. Therefore, these graphs will be one and the same. So no change in the nature of the graph. Maybe slopes and all those numbers or magnitudes changes, but nature of the graph will be same. Supposing here I said this is kinetic energy, intensity versus kinetic energy. Whenever I say kinetic energy, I have told maximum kinetic energy only. Intensity versus kinetic energy. Earlier, the concept of characteristic was independent of intensity. Kinetic energy depends only on the frequency of incident radiation and of course nature of emitter if it is changing. Therefore, it is independent, does not depend. Though I changes, K remains same. Therefore, it will be a straight line parallel to intensity axis. Supposing the same is asked in the case of photocurrent also. Photocurrent versus frequency graph. What will be the frequency graph? Yesterday we have told that saturated current independent of frequency. Therefore here it will be again straight line parallel to frequency axis, because independent nature whenever comes, that will be parallel to x-axis. Now supposing if it is kinetic energy versus frequency, kinetic energy versus frequency, then what is the relation? What is the relation? And the result is that you remember kinetic energy K maximum is equal to Hf minus Hf naught. This is in the form Y is equal to mx plus C form you have. Mx plus or minus C form you have. Therefore, it will be a straight line with the positive slope and a positive x-intercept, and of course if you extrapolate it, it will have negative y-intercept, positive slope. And do remember, this slope is now independent of the emitter. If emitter changes, the slope does not change. Why? Because yesterday we have given that Einstein's equation verification, the slope is nothing but h by e. It's a universal constant. Whereas the x-intercept and y-intercept, they depend on the nature of the emitter. Because now here you see, what is this x-intercept now telling you? This x-intercept will tell you the threshold frequency, which depends upon the nature of the emitter. And at the same time, this y-intercept also, you see, this is what is h times f naught you are getting. So h times f naught you are getting, again this is also a character y-intercept depending upon the nature of the emitter. So this is kinetic energy versus frequency, and as I have told you, stopping potential and frequency graph was also the same, but the only difference is that, now please see here, if it is kinetic energy versus frequency, the slope is equal to h here. Can you see? Now for this graph, what is slope? Slope is equal to h. If it is stopping potential versus frequency according to our yesterday discussion, then the slope is h by e. But here only kinetic energy frequency graph slope is h, x intercept which is positive is f naught, and this h f naught, this represents nothing but work function, is it not? Because h times f naught was our work function. Therefore, this y-intercept representing work function, x representing f naught, slope representing only h. Yesterday we did the case of stopping potential versus frequency. So there you will find a change in the intercepts and the slope, but the nature of the graph will be the same. So these are the different graphs that we come across in our photoelectric effect. Now, tomorrow an assignment will reach you on this topic, and do practice well. For your Sunday examination, you will also have the questions on dual nature of matter and the previous two chapters like alternating current and EMI. So based on 3 chapters, you will write your next Sunday examinations. Prepare well. Have a very, very good day. Thank you.